Hi, greetings everyone. Thank you for joining us at Exchanging Ideas 61 Global 5G Evolution. To the audience, please take a couple of seconds to click the subscribe button on our YouTube channel. I'm Kanishwaran Govindasamy, the founder of Global 5G Evolution, and I would like to uh, have a warm welcome to all the speakers. And today, during the Q&A at the end of the session, will be a fantastic discussion among the speakers to discuss how should the industry stakeholders, which are the automakers, telecom providers, infrastructure operators, and regulators, will collaborate to treat 5G, V2X, and autonomous driving as an integrated ecosystem rather than fragmented technologies. Now, without due delay, my topic presentation is on software-defined vehicles revolutionizing the automotive industry. I'm giving my point of view on the artwork slides by PwC. And just to give an highlight of the software-defined vehicles are transforming the automotive industry by decoupling hardware and software, leading to new value pools in software and electronics. While Chinese and US players are ahead in SDV maturity, European OEMs have growth opportunities but face risk if they fail to adapt. Success will require OEMs and suppliers to change their operating models, close capability gaps, and form effective partnerships, especially with tech companies, to balance innovation and standardization. Now, a SDV is a car that relies on digital tech where all functions such as driving, in entertainment, safety, and comfort are managed and customized through software. SDVs are cloud connected, allowing new features to be added over the air without hardware changes. And the key characteristics of SDVs are the separation of software from the hardware, which enables scalability, faster deployment, and integration into digital ecosystems. This slide highlights the key benefits of SDVs for both OEMs and customers. For OEMs, SDVs offers reduced cut-through, fewer recalls, and less specialized hardware, shorter time to market via rapid development and easier integration, and the potential for differentiated business models like subscriptions. Customers benefit from upgradability and flexibility through the over-the-air updates, a modern user experience with personalized interfaces, seamless ecosystem integration, and third-party apps, which will increase the performance via data-driven improvements and improve safety and security features. Now, when it comes to disrupting the automotive value chain, the product technology and architecture will see the rise of software-based functionalities and extended product life cycles. This will lead to new value chains and new industry players entering the market, requiring new strategies like partnerships and co-innovation. The way to play will evolve with new value propositions and competition focuses. And finally, the operating model will shift towards new organization structures, continuous development, and integrated tool chains. This illustrates the layered software and hardware architecture, which is essential for the SDVs, emphasizing the independent development and operation of software from the hardware. And the architecture comprises in-vehicle layers, which is the applications, the extended services, basic services, the compute, sensors, and actuators, and also the cloud layer. And this separation facilitates a layered designation to hyperscalers, enablers, modular software development, faster update, and the combination of functionalities across different layers via standardized APIs. The architecture also indicates elements for digital lifecycle management, development tool chains, and security management. Now, this is quite interesting in terms of it explains that the degree to which different vehicle functions are integrated into central computing units depends on the specific requirements of each domain, particularly the advanced driver assistance systems, autonomous driving, and infotainment. It also suggests a trend towards greater integration, moving from ECU to zone and eventually central compute architectures, and potential leveraging the cloud. The Chinese vehicle models are currently uh, in advance in terms of SDV characteristics, surpassing the US and EU competitors. The evaluation shows that the automakers lead the market in software, electric architecture, software update capabilities. The Chinese also excel in user experience and ecosystem integration. However, European manufacturers maintain a lead in automated driving, safety, and security. Overall, China is at the forefront of the SDV transition, particularly in the software maturity and integration, while Europe leads in advanced safety and automation features. A comparison scenario, how SDVs differs across Europe, US, China, based on the technology, customer, and regulatory factors. Europe is characterized by OEM-led partnerships, time to market, conservative customers, and fragmentation regulations, leading to an OEM partnering SDV scenario. The US features a balance between the conservative incumbents and innovative new entrants, a strong digital consumer ecosystem, and a localized regulatory hubs, resulting a balanced power scenario. In contrast, China is rapidly advancing towards the SDVs with strong tech players, fast time to market, tech-savvy customers, coordinating regulation, and robust steel support, making its SDV scenario distinctly tech-driven. This illustrates how automotive OEMs are transitioning to an architecture-led approach for SDV platform development, fundamentally changing how they collaborate with suppliers. And by establishing a unified SDV vehicle architecture, the OEMs can streamline both software and hardware development using a single software team for regular coordinated software releases and a single hardware team for defining and updating the component kits. And this enables individual vehicle projects to efficiently combine and approve the hardware and configure the latest software for specific models, brands, and the target audience. The OEMs should customize the partnering strategies according to the differentiation and complexity of each vehicle component, aligning with the overall EE architecture, electronic and electrical architecture business goals. High differentiation, high complexity areas like power electronics and centralized ADAS infotainment benefit most from in-house development or close cooperative partnerships to drive innovation and brand value. In contrast, components with lower differentiation and complexity, such as ABS or body parts, are best sourced through transaction-based partnerships to maximize efficiency and cost effectiveness. And lastly, given the rapid transition towards SDVs, the automotive players need to act quickly by defining a clear SDV strategy and market position, shifting to a regional perspective to enable customization and regulatory compliance, and embracing hardware independent software architecture for continuous development and third-party integration. Furthermore, they must master diverse partnership strategies tailored to specific configurations and modernize their developments with cloud-native tools, the CI/CD frameworks to support real-time updates and assure the effective collaboration throughout the life cycle. So I think this is overall of my slide, and I would like to welcome our next speaker, Giovanni King from Willemstad, Curacao, to present on data centers and vehicle connectivity. Over to you.
So thank you very much for the opportunity to be part of this ecosystem and doing a small presentation on where we see or where I see connected vehicles in the Caribbean. It's very important to realize that we are a very diverse area consisting of approximately 34 islands, each with its own diversity challenges, but and population sizes, which can also be a limitation, considering that most of our islands have a population size that's less than 500,000, and all of the challenges that this brings with it. So what I'm going to try to look at is to give you an impression of what are the challenges that we're dealing with, where we stand when it comes to data centers, and where we stand as it comes to the position of sustainability, as we are a region in which our primary economic pillar is tourism. So you can understand that sustainability for every new technology that we're trying to bring into the region, we would like to see what the impact of that is on that ecosystem. So with that in mind, what I'm looking at today is the role of the data center, of course, the infrastructure to support connected vehicles, looking at both the electronic communications infrastructure, the physical roads that we need to navigate, and what the challenges are there. Again, talking about small islands, sustainability, and the options of using regulatory sandboxes to see how not all islands need to go through the same learning curve, but to learn from each other and learn from other countries that are already gone through the same process. To bring everything into context, the Caribbean consists of multiple small island development states, each with its own mobility needs, each with its own geographical challenges, some hilly, some flat, some volcanic still, and others a combination thereof. The region is going, of course, just like the rest of the world, through a growth of digital infrastructure as governments and the adoption of technology. As governments go through the process of digital transformation and the region is building its own digital economy, the investment in electronic communication infrastructure, the investment in data centers, the investment in internet exchanges, all that are very important for this whole ecosystem are being invested in. Again, all of this done with the emphasis on sustainability. Again, when we look at the different islands, what we again see is that size matters in this particular case, and based on that, our region historically has had a challenge where infrastructure was built where connectivity always led to the north, meaning that connectivity between two people on the same island would be routed through, for instance, mainland US and then come back. This would result, if we're talking about connected vehicles, that there would be a major process of latency, because by the time the vehicle would try to connect with, be it sensors on the roads or devices or any other form, or even with the next vehicle to make decisions on do I move forward, do I slow down, or whichever thing like that, the latency would have a major impact. So as a result of all of this and the digital transformation process, governments have been investing and private entities have been investing in creating and building data centers in the region. The region represented by a regional organization, Caribbean CARICOM. CARICOM has put out policy documents that talk about creation of a single market and economy and a single ICT space. With a single ICT space, what we're trying to do is to connect the islands to each other through physical connections, routing our traffic locally and regionally, which would mean that we are minimizing latency, which are very important for this process that we're going through. The data centers, of course, play a role of enabling the lower latency when it comes to vehicle-to-everything communication and applications, the support of data localization and data sovereignty, because we're collecting and creating a lot of data that we would prefer to have within our own region as opposed to being hosted outside of the region. Having the data closer to where it's needed would only create a better quality of service as applications try to speak to each other, devices try to speak and communicate to each other. To manage all this potential or the growth in data, it's very important to have the data centers in the region, as they will be enabled to deal with the AI workload and the GPU as a service that would enable this connected vehicle systems. Without those, or only relying on hyperscalers in the US, would mean that this development wouldn't reach the region in a efficient or effective way, if you want. So when we're looking at some of the challenges, because before you do anything as a engineer, I think I always go to the basis, to the foundation. You need to have roads that are capable, in which you can put in all of the sensors that are required and all the basic needs in order to facilitate and create the learning languages, modules that you need to enable communication between vehicles, devices, applications, and all of these. Some of the challenges that we are facing are some deteriorating road conditions, poor signage, unclear road markings, inadequate lighting, and these issues all affect the vehicle safety, but also hinder the effectiveness of connected vehicle technologies that rely on clear road markings, consistent infrastructure, and optimal performance. Again, without this basis, it wouldn't be feasible to have these cars used in a safe manner. So, and these conditions vary from island to island. When it comes to our electronic communications infrastructure that we have in the region, I must say that basically all islands have at least 3G networks, and most of them also 4G networks. But when it comes to 5G, which is the basis for support of connected vehicles, we are still lagging behind. As small islands, the investment in creating this infrastructure is very costly. So the process of doing that upgrade is taking longer than you would expect in other developing countries. In general, not only the investment is very great, but our islands are also within what we call the hurricane belt, meaning that on a yearly basis, most or some of the islands would face major hurricanes, flooding as a result, and this all impacts what I have just stated, the quality of the roads that we have, and even the digital infrastructure, because on some islands you could still have over the head hanging fiber optic cables moving from pole to pole. In the case of a hurricane, all of this can be down, and this, of course, not only impacts communication, but also access to data centers. Even the data centers need to be built to withstand higher category of hurricanes, to not only guarantee the safety of the data, but to also guarantee that governments can be up and running and systems will be up and running shortly after such an event. Again, looking at sustainability, as I don't need to tell nobody here that once you start looking at the use of data centers, connected vehicles, the consumption of data, the power consumption also increases. Most of our islands still depend on on fossil fuels for the generation of electricity. And this would mean that as the consumption and the use of data center increases, the consumption of electricity also grows. And this would have a negative impact on our carbon emissions. And this would be a challenge between trying to maintain our most important economic pillar, which is tourism. Having that balance between tourism and sustainability would be something that, from a regulatory prospect, we would need to look into. So being sure that we have a plan to transition to solar, wind, even geothermal energy generation is the path forward when it comes to the usage of connected vehicles in the region. Looking at the data centers are using efficient cooling and modern cooling. The data center that I manage, which is Blue Nap Americas in Curacao, we're currently looking at using a system called ocean water assisted cooling in order for us to lower our carbon footprint and to maintain our most recently gotten sustainable data test center certificate based on the ANSI certification process. So governments needs to put policies in place to incentivize the use of renewable energy in order to sustain this development. When we're looking at the infrastructure, we need to have policies in place to prioritize and upgrade our roadways to meet standards required for the connected vehicle technology, include improved road surfaces, signage, and lighting, digital expansion, invest into expanding digital infrastructure, focus on increasing broadband connectivity when it comes to specifically 5G deployment, because as I indicated, 3G and 4G are basically mainstream. And then again, looking at using renewable energy in order to lower the carbon footprint as we are using and analyzing the data that is collected and created by these vehicles. Again, in order for us to be sustainable, it's not only about energy consumption, but we're looking at three pillars. It's the environmental sustainability, economical sustainability, and the social sustainability, with all three of them being as of the same importance. Everybody needs to be benefiting from the whole developing process. When we're looking at the controlled environment, when it comes to regulatory sandboxes, if we can use this, we can create an environment in which we can test and innovate. We can look at how to support communication when it comes to vehicle to X, and also looking at what we need to do with data privacy. Basically, based on these two elements, currently in the Caribbean, what I see is that Barbados, Jamaica, Trinidad and Tobago, and Curacao are in a position to lead this process forward. Some recommendations, if we would look at the region, I would say we need to develop connected vehicle standards, and we can use organizations like CARICOM and the Caribbean Telecommunications Union to lead the process. We can expand on our data center capacity in the region, expand on our 5G coverage, establish mobility-focused regulatory sandboxes to help us navigate the challenges that we know we're facing. And through these sandboxes, track the sustainability KPIs, and also doing that in the connected vehicle projects. And last but not least, I think that the region, because of our size and scale, we can play an important role when it comes to innovation within this ecosystem by doing the right investment in infrastructure, so and policy making and sustainability. Collaboration between governments and data centers and the private sector is key to achieve that. With that, I hope I gave a vision or an indication of where we stand as the Caribbean. And of course, in a later stage, always happy to answer questions as I leave my contact information here.
That was fabulous. Thank you so much, Giovanni. Thank you. That was a great presentation. Let me introduce our next speaker, Lauren Pawlowski from Seoul, South Korea, to present on what about an app store for cars. Lauren, would you mind to unmute us?
Yeah, I was mute. Sorry for that. So thank you, Kaneshwaran. So yeah, my presentation will be about App Store for cars, and why that? Because actually, recently I got contacted by car manufacturer, whether actually it's not my industry at all, and they were asking me how can we make an App Store for cars. So why did they contacted me? The reason is because the Android-based alternative app store has been created 16 years ago, and I've been working for that industry for 15 years, including 10 years in Samsung, 3 years in one store, and 2 years in Unity for different alternative app stores. So the first thing that I was telling to this car manufacturer is, what is your goal when you want to create an app store? Is your goal monetizing? If your goal is to monetize, you have to keep in mind that Android alternative app store are not making money. They generate a lot of money, but the bottom line is negative. And you have to think that some of them have more than 300 million preload per year. So you have to think with my cars, in how many car on my App Store will be embedded. So the second goal that you might have is to add value to your user. So it will be like something like enhancing the user car experience for the user. But you have to think that you have to make something better than just the mirroring of cell phone inside of your car. Otherwise, it's useless to have an app store. So the goal could be actually both, but if it's both, then I would suggest that you start by trying to add value to your car for the user. So the first technical thing that you have to think when you make an app store is what is the OS that will be running my app store. So many, how to say, car manufacturer would think, oh, I need my technology, my OS. But the problem that you will be facing is you have the chicken and egg circle. Because actually, when you want to have, when you want to source the application for your ecosystem, the first thing that the app developer will ask you is how many users do you have? But of course, if you are just launching your app store, you don't have any user. And then you have the other problem, why the user will come to your app store if you don't have any application. So creating your own OS and making your app store based on that as, how to say, some big struggle at the beginning, that you will need to convince the app developer to make app for your ecosystem. Since you don't have traffic that you can trade, you might need to pay them. And even though you are ready to pay them and pay them even a lot, some of them might refuse just because they don't want to do that. And if it's regarding a critical application, such as, Waze, for example, which is pretty much used as the main navigation in Europe, you will have trouble for your app store. So you might think maybe I need to emulate that application, but then you go back to the origin of the original problem is, do you really need your own OS? Maybe having an OS based on Android would be safer for you in order to not go into that issue. So it will be the same issue, of course, if you use not your own OS, but another OS like WebOS, for example, because you will face the same issue. So when it comes to App Store, you might think an App Store is an App Store, but actually there are many different types of App Store. So the first type of App Store that I would describe is probably the one that is the most well-known. It's similar with Google Play, so it's what we call in-app purchase-based App Store, like Galaxy Store or Huawei App Gallery. So it's an App Store where you require the developer to include in the application your own SDK. So the problem that you have is you need to convince all these developers to include your own SDK. The second type of App Store is the Vault type of App Store, which is like APK pure or up to down. So here you don't need to ask the developer to include your SDK because basically they come with the Google Play version. But the problem that you have is whenever there is an in-app transaction, the money goes to Google, doesn't go to you. So you need to find another business model, which is either ads or something else. The third type of App Store is what we can call the window type of App Store. It's a lighter version than the Vault type of App Store. You can think of like the Samsung Game Launcher, where actually all the apps that you see in your App Store are actually just linked to Google Play. So it's different than the Vault type where you own actually all the application on your own server. Here you just basically distributing link for Google Play. So it's lighter, but it's more restrictive in terms of geolocalization. The fourth type of App Store is a cloud-based App Store like now.gg. But the problem is, as you know, cloud-based App Store, it has a high running cost and you need always to require connectivity. But there is another type of App Store, which is what I would call the hybrid type of App Store, which mix two of the type of App Store. For example, Aptoid or QApp, it's basically a Vault type App Store. It means that they have all applications that they want from Google Play. But when they reach an agreement with a developer, then with these developers, they make a specific version, like on the IAP-based App Store solution. So I would suggest actually to adopt the hybrid model of App Store. So when it comes to App Store, can you think about innovation? Because if you just have, how to say, the same as Google Play, then it's not really useful. So I would think two technology could be, how to say, helpful to innovate. First would be AI. If you have like a GPT level AI where you are able to converse with the application, and you are able to launch the app and the in-app comments. So for example, you know, in the application that are applicable to your car is about like 200. So you could actually integrate your AI with all of these applications. So you could launch actually a command of any application from your AI. And the second technology is cloud-based. And why it is? Because as you know, when you want an application, you need to download it. And sometimes some applications are really big, so it takes time. But if you have a launcher, which is cloud-based, it means that once you enter in your car, the applications are available. And once you use it, then your app store will download this application on the background so that you can launch it natively from the next time. So what is the benefit? So of course, it's instant setup. You don't need to wait to download. When you enter in your car, like Kit, you are able to talk to your car and launch application or launch directly what you want to do. And the AI will find the proper application and launch it with the proper command. And you have also the reduced risk and safer experience because you don't need to touch a screen. You just need to speak basically. In terms of monetization, so the traditional ways is, of course, in-app purchase and ads display. But this model are a little bit weak in terms of monetization if we apply for other cars. So immersive ads might be the proper way, which is whenever your AI, whenever you talk to your AI, your AI actually could recommend or by default use certain application and you would monetize actually this choice. So to summary and to give my recommendation, if you have to build an app store for your car. So as a first goal, you need to have the user experience first before the monetization. And when you have that, after you can go on the monetization. For the OS, I recommend to use Android. For the App Store type, I recommend the hybrid type, Volt plus IAP. To enhance your user experience, I recommend you use two technologies, which is the most straightforward, AI and cloud. And for the monetization, you could use potentially in-app purchase and ads, but I would see a business model via ads via the AI recommendation. And that's the end of my presentation. Thank you.
Oh, that was fantastic. Thank you so much, Laurent. I really appreciate for your presentation. Now, let me introduce our next speaker, Frank Chendow from Atlanta, USA, to present on evolving teams into the future of cars connectivity. Over to you.
Well, I mean, I'll thank you first off, for the opportunity. I guess what I would like to present to you today has very little to do with technology per se, but more to do with people, teams, and so on. If you don't mind, I have very little to show today. It's only one slide, right? Let me do that. It's going to take me only a few seconds here. Okay, just in time. And here we are. Can you all see my screen okay?
Yes.
Right, great. Should be now even better. I guess, the first thing I would like to start with has to do with our speed of evolution. We live in times with rapidly changing and evolving things our world has ever experienced before. This is quite uncommon in the history of humanity. There hasn't been any similar times before, right? The speed of technology has taken us from mobile phones, if you remember the Samsung or the Nokia, to iPhones, for instance. Think about all that and try to reflect that change or those advances into car industries. What I'm trying to say here today is probably portray how technology has transformed that car industry. And that wouldn't have happened if not thanks to connectivity. And what is connectivity here? It's first off a very, very powerful word, and the way it brings us together, not only humans, but also our cars, and how we connect both hardware and software to make the, just a moment, please. I'm struggling with technology here, just a moment, please. Can you still hear me okay?
Yes, yes, I can hear.
All right, sounds good. I'm competing with, technology. Sorry for that. So anything, sorry, I need to change location. I'm completely sorry for that. The point that I meant to make today is evolving teams into the future of cars connectivity. What does that really mean? If cars per se operate on the basis, cars nowadays operate on the basis of software and hardware, my very first question to you will be, what will be the human software and what will be the human's hardware? People refer to that as that brain and heart coherence. If you're familiar with, say, for instance, the framework by Jeff Leffingwell, that was in fact invented in 2011. One of the core principles that SAFE refers to is tapping into the intrinsic motivation of knowledge workers. What does that mean per se? What that means is transitioning teams into a position where they can operate on the basis of flow. And the only way for flow to operate and to work so well and deliver results that I expected will be to establish that firm connection between the brain and the heart. And I know this is not a typical topic that tech people, venture in that easily, but I would guarantee you with so much proof and evidence that this is the only way for us to not only further this connectivity at the cost level, but also evolve our teams to the same pace. I mentioned, and I'm just about to mention, equilibrium. What does that really mean? What I mean by equilibrium is if we are to track the pace at which our software nowadays is evolving, you will notice that 10 years ago versus today, we've accomplished so much. I will not get into the details because you are all aware, even more aware than I am. I would say that equilibrium translates into speed at which cars are evolving or technology is evolving versus speed at which humans or teams per se are evolving. If the two speeds are matching, you have equilibrium. And whenever that doesn't match, you have system imbalances. Imagine a world where people or technology will be at its peak and only 1 or 10% of tech teams would have the luxury of navigating through that system through comfort. What about the 90% of all the other tech teams that have little access to such potential? What I'm referring to here is a way or specific training, specific ways to transition our 90% to that 10% dimension of brain and heart coherence, where all those teams are not only evolving at the same pace as technology, but also are achieving at the same pace as the 10%. I mentioned SAFE before because when Jeff Leffingwell came up with that system in 2011, this is just about 14 years ago, he listed 10 principles. I would have loved to come up with the slides, to show you all of them. I have some of them listed right here. Let me share the screen per se. Okay, I don't know if you can see my screen, but if you cannot, please let me know. There are 10 of them. I will not dive into all of them, but the key one, if not the main one I would like to discuss with you today is the one that relates or that mentions brain and heart coherence. And I'm pretty sure many of you are familiar with that, but being familiar with the concept is one thing, but applying that concept in our day-to-day work is another. I'm mentioning this because this is the only way for us to establish that equilibrium between the pace at which technology is evolving and the way our teams, our dev teams are nowadays. On this, I will close this presentation. As I told you, it was very short, only a one-sider, and that will be all for now. And I thank you for your time, for your attention, and for the opportunity.
Brilliant. Thank you, Frank. I appreciate that.
You got it. Sure.
Now, all right. So now let me introduce our next speaker, Gordana Stojkovic from Belgrade, Serbia, to present on edge computing and vehicle connectivity. Over to you.
Thank you. Just to share, can you hear me?
Yes.
Yes, okay. Just to share my
Yeah, let me introduce our next speaker, Sunil Gowda from Krakow, Poland, to present on V2X in Indian roads. Over to you.
Okay, thank you, Kanish, for giving me an opportunity to explain what is CV2X and how CV2X is taking traction in India. So, myself, Sunil Gaudar, and I am a 5G enthusiast, and I'm doing all the little bit activities on the 5G part, which we could able to deploy in India as well. Okay, and coming to my academics, I have secured few gold medal, and I'm a state rank awardee in my academics. Yep. So in today's session, I'm going to discuss about how CV2X could be deployed in India and what are the consequences and how we could able to overcome it. Okay. Yeah, so coming to the first part, understanding the CV2X technology, and I'm sure you guys already know what is the CV2X technology, and this is just a overview. So now, to understand the high level of CV2X technology, now we have the communication scope. When you talk about the communication scope, vehicle is going to talk with other vehicle is going to talk with the infrastructure and pedestrians and the networks directly. Okay, why directly? Because to avoid the latency part, okay, where the 5G is going to come into picture. So when you say C is basically for cellular based. Okay, now coming to the technology part, it works on the licensed band, where in US and Europe there is already a licensed spectrum available for the CV2X to make use of it. And now, what are the applications for the CV2X? So the applications could be the collision avoidance, and the main intent of this is to have a road safety and also for the traffic optimization. So now when you say traffic optimization, when all the traffic intersections are connected, so the vehicles would be knowing predefined, stating that, okay, in the next signal at what time it is going to be green, okay, and what time it was going to be changed to red. Okay, so that in that way the CV2X technology could able to help the traffic optimization and could have a clear traffic picture. Okay, so a few examples of the CV2X technology can be emergency brake alerts and work zone warning and speed advisories, and there are a few other applications also, but on the high level I've just kept based on the time limitation. Okay, so what are the challenges that currently we are facing to deploy the CV2X in India? As one is the regulatory gaps. So when you say regulatory gaps, since each country works on different frequency bands, okay, India should also allow a few standards to make the CV2X to work in Indian roads. Okay, So still there is a discussion going on to make this licensed spectrum or having the perfect bandwidth for the CV2X to work. Okay, so that is a main challenge which we are facing in India. And next would be the diverse vehicle fleet. As you already know, in India we have a diverse vehicle fleet: four-wheelers, two-wheelers, three-wheelers. Okay, and when you come to the commercial part, we have 12-wheelers. So okay, there is a diverse vehicle fleet. So for that also, the CV2X should be adhered to. Okay, and the third part would be the infrastructure deficit. So currently, in India, there is no more roadside units have been placed for communicating between the vehicles and the infrastructure. So if that is also one of the part where infrastructure deficit is also the challenges which we are facing in India. And the third part would be the security and cost. So since the cybersecurity is becoming a challenging part nowadays, the security for the CV2X, basically exchanging the data between vehicles to vehicles, is more what to say, vulnerable. So we have to see on the security and obviously the cost. Okay, so these are the four different areas which in India to deploy the CV2X part. Okay, now what could be the solution for these issues? What could be the solutions that we can give it to CV2X to deploy in India? So one would be the policy regulation. So we have to somehow do a government driven activities stating that what could be the advantage of CV2X, so that multiple or more lives would be saved on the roads. Okay, and second would be the collaborative deployment. Yes, this is very much essential, where all the stakeholders, OEM, tier ones, and the enthusiasts, and all the new entrepreneurs, and so many people who is very interested on this 5G and CV2X. So they all have to be collaboratively work on this part to make a successful on the roads. Okay, and the phased rollout, yes, phased rollout is very much essential. Why? Because we can't deploy a mass deployment in the CV2X. So the phased rollout is really essential. And the local innovation. So there should be a lot of R&D part, and they have to take each and every roads or the junctions to make sure the CV2X is going to be really useful in that particular junction, so that it is a chain link from the local innovation to the policy regulation. Okay, so these are the solutions that we could able to give for the CV2X deployment issues. Okay, and what could be the impact of CV2X on Indian traffic roads is, one is the safer roads. So more than 80% of accident reduction could be saved if the CV2X is effectively work on the Indian roads. Okay, and second would be the smooth traffic flow. As I already told, if all the traffic junctions are interconnected using the CV2X technology, the CV2X traffic flow, okay, or we could mention it as easy traffic flow. Okay, and the third would be the efficient public transport. Since in India still the efficiency of the public transport has to be improvised, so by having the CV2X, let's say now in the tolling part, highway tolling part, so CV2X would be more essential, is what all the research is saying. Okay, so likewise we could able to improve the efficient public transport as well. And the fourth one would be emergency response. So now the emergency response can be the hospital, when the hospital is connected to the ambulance, and ambulance is connected to the vehicles. So if there is some action or some accident happens, so it could able to get a immediate response, okay, from hospital to the emergency vehicle and to your vehicle. So they all three are interlinked. That can be happened. Okay, probably Kanish, my screen is not sharing.
Seriously, I have no idea what's going on. Would you mind to share again?
Yes,
Good.
yes. One
Yes.
second.
Yeah.
Let me know. Could you able to see now?
Yes.
Okay,
Yes.
perfect. So these are the impact that we could able to see when CV2X is there on the Indian roads. Okay, and the other would be how we could able to enhance, okay, the road infrastructure is, first and foremost, yes, RSU development. When I say RSU, it is a roadside unit, where roadside unit can be deployed in all the places across the globe as well. Okay, and second would be the system integration, where the RSU could able to talk with your vehicle, so that the OBU, the onboard unit, which we are going to place in the vehicle, okay, should has to be integrated with other OBUs, so that whatever the data that we receive from the roadside unit, okay, it could able to diversify to the other OBUs. Okay, and the network investment. So the network investment is really essential, since the CV2X work on the 5G part. So how this URLLC and EMBB, all this going to be connected to the car. Okay, so for that, network has to be established, of course. Okay, that is also one of the part. And the OTA updates. So since the vehicle has to be, since once the CV2X is on the vehicle, okay, the new updates has to be eventually needed. Why? Because the 5G, the software parts and all has to be invoked into the CV2X. Okay, so these are the few areas where we need to be enhanced to put it on the Indian roads. Okay, and what are the current limitations that we are facing in the CV2X without 5G is, yes, one is the latency issues. As we already know how the latency issues work without 5G when we have the 4G network, and the bandwidth limits. Yes, since there is a huge volumes of car on the roads, there would be a bandwidth issue can occur. Okay, and the network congestion, yes, network congestion is there in the 4G part. That is why we are all moving to 5G network now. And the examples, let's say, when I say examples, if there is any delay between the collision, okay, there is a huge drastic accident would happen, right? So these are the current limitations without 5G when we are going to deploy the CV2X. Okay, and how the 5G could able to enhance CV2X capabilities, since the core 5G features would be the URLLC, EMBB, and MMTC. When you say URLLC, it's a ultra reliable low latency communication. This is very, very essential for the automotive department to make sure we don't lose even a milliseconds of data to take a action. Okay, so URLC is a crucial for automotive, and EMBB, since high volume or high density of vehicles are on the road, this EMBB plays a major role, which says enhanced broadband for large data to be transferred. Okay, and MMTC is basically more machine type communication would have been transmitted and received. Okay, so using these three concepts, we could able to overcome the issues that we are facing currently in CV2X for Indian roads. Okay, Indian roads as well as globally. Okay, when you say globally, in US, we have Ann Arbor test bed. So there is a lot of traction is happening in the US for the CV2X. Okay, and the 5G is really helping out the CV2X to be deployed in the cars. Okay, and in Europe, there is a concept of C roads. Okay, where they are doing a lot of interoperability testing across the globe to get this CV2X efficiently, because the CV2X is going to be supported for the software-defined vehicles. So since the HPCC, which we say high performance computing, okay, for that we are going to put the CV2X processor, so it will be more efficient way of working for the SDVs. Okay, in China there is a large scale deployment is already started for the CV2X, and in India, as we already told, those are the lessons tailored from different parts of globe, and they are in the adoption. Okay, these are the global best practices and adoption that they are doing it. So coming to the last, the conclusion would be for having a smarter, safer, and futuristic India, CV2X is really essential. Okay, and the collaborative effort is really required. Okay, and the strategic deployment, as we say, the phased rollout and the networking investment. Okay, so all the strategic deployment is really essential to make the CV2X to deployed on the Indian roads. Okay, the vision I had would be the platooning. For the platooning concepts, the lead vehicle, let's say, we have 10 vehicles and the first vehicle is having, let's say, in the 100 meters, and you have to get all the data to the last vehicle. Okay, so for the platooning also, this CV2X is really essential. Okay, so for having a better, smarter, safer, and futuristic across the globe, CV2X is really helpful. And yeah, thank you so much.
Thank you so much, Sunil. That was fabulous, fantastic. Appreciate that.
Thank you so much, Kanish, for organizing this.
Yeah. Okay, let me introduce our next speaker, Adam Kadzila from Warsaw, Poland, to present on EV as home energy storage. The future of energy efficient houses is just around the corner. Over to you.
Hi, everyone. Thank you for the invitation. Before I turn the slides on, I would like to tell you about the approach I'm going to show you. Like, I was inspired by the previous presentation, but what we're doing at Evert with vehicle to grid business model is completely different approach to a vehicle connectivity and how we're gonna use that, and what kind of future awaits us with electric vehicles. First of all, what is vehicle to what is bidirectional charging? So at the base of electric vehicles was to use cars as energy storage. If you remember, that was one of the promises of Elon Musk when he began his journey with Tesla. He said that cars of the future will be used to power our houses and stabilize grid. And it's fast forward 10 years or 15 years forward, this is still in the works. And actually, Tesla and Elon Musk are slowing that progress down. But cars in future will be important part of our energy systems and will be used to stabilize the grid, and will be used for homeowners and company owners to get energy independence for the businesses and homes. What we see today is unidirectional charging, meaning electricity flows only in the direction of cars to charge it, that we are able to drive it. Bidirectional charging means that energy can flow in both ways. We will be able to charge the car, but also use the energy from the car to charge our house. Meaning, when the energy is cheaper, we can charge the car and then use the energy for our business or house. When the energy cost is higher, or use solar photovoltaic systems to power up the car and then discharge it at night. We have 4 different V2X, as we call it in the industry, technologies. Vehicle to load, meaning where vehicle serves as a mobile electricity source for external devices. For example, it can be used on construction to power tools used to building in the building environment. Vehicle to home, this is technology used to power your own house from your car. Vehicle to building means for bigger systems to power up the whole company or school or a shop. And then the final one, vehicle to grid, where cars interoperate with a grid to stabilize the energy grid production and distribution. The financial potential of bidirectional charging is huge. Only in Germany, and we at Evert, we focus on the German market first. The potential to reduce the investment in the grid expansion is count up 8.4 billion euro annually, and for the whole European Union, it's about 22 billion euro annually. It's a huge amount of money, and European countries have to invest heavily in grids, and using car to stabilize the grid is one of the enablers to actually lower the investment rates. What are the other effects on electricity prices when we use V2G technology? Is lowering peak loads, meaning we can reduce expensive peak loads and reducing need for grid and for reinforcements. Another one is optimal use of renewable sources of energy, meaning photovoltaics, wind, and hydro energy. Less need of stationary storage devices. So instead of building energy storage system based on batteries, we can actually use our batteries on wheels, meaning cars, to stabilize the system, and utilize better solar panels by charging the car when we have sunshine and discharging when discharging it at night. This is calculation made by Fraunhofer Institute last year, trying to figure out how much normal, like standard family in Europe can save with a electric car and with a vehicle to home, vehicle to grid, a compatible charger. And in Germany, it's up to 700 euro. The least one is Poland with 422 euro, but with much less energy use for the home. It's enormous savings that can be put on top of the solar system, and we have to remember that this technology doesn't require to build a specific energy storage system at your home or in your garage. You actually use your own car as a storage. So from my perspective, we will market our solution as, buy yourself a new car, because your new car will actually work for you and save money or even generate money. Of course, the problematic side is the saturation of the market with electric vehicles capable of vehicle to home or vehicle to grid. The number of the cars today accounts for in Germany for about 1 million cars, which is still a small percent of the market. But as we see on the graph, it will be rising rapidly in following years. This is the list of V2 home or V2G enabled vehicles today on the European market, and those vehicles are marketed as ready. The reality is a bit different. There are a few other models, and there are a lot of Chinese cars coming into Europe now that are also sharing the ability to be charged and discharged. But we have run at ever test on many cars out of this list, and we are successfully able to discharge and charge any car that can be charged with a DC cable. So this is very important. Any car can be used in that model. So what we do at Airwood, we designed device we call PMU, so Power Management Unit. It's a comprehensive solution that enables you to charge and discharge your car, but also you connect this device to solar panels and use it as inverter to be able to use solar power to charge your car, to power your home, and also connect external battery system to support your house when you drive your car away. So our solution is also supported by energy management software to schedule energy storage, to control the consumption, to trade energy with the grid, and all of that is supported with AI-powered energy optimization. And we have some feature also for cost saving, and everything connects with also modern energy management system for homes. I also prepared a little table showing how vehicle to grid solution can bring revenues to small companies. So in this example, we analyzed a small company where it's a small sales company running in Germany with a 10 people service team with 10 cars. And those cars have 77 kilowatt batteries. Daily distance for each salesperson is 50 kilometers, so they run pretty close the company. And daily energy demand per vehicle is 10 kilowatt. So with 5 bidirectional chargers from Avert, with investment of around 35,000 euro, the payback period for this kind of system is approximately 4 years, being very, I would say, lucrative for a business owner. And we have to take into consideration that the investment today, meaning those 4,000 euro per charger and 2,000 euro for installation, is very high, as this is the newest tech on the market. If you would like to hear more from me about what we do at Evert and what's the future of vehicle to grid and home and small business optimization, please contact me using email or phone me. I'm also available on LinkedIn. Thank you.
Awesome. That was brilliant. Thank you so much, Adam. I appreciate that. Thank you.
Okay.
Let me introduce our next speaker, Gordana Stojkovic from Belgrade, Serbia, to present
Exactly.
on edge computing and vehicle connectivity. Over to you.
Yes, hello everyone. Sorry for this a little bit inconveniences. Anyway, I am Gordana Stojkovic. I've spent over 25 years as radio engineer optimizing mobile networks around the world. And today I will talk about edge computing and vehicle connectivity. And generally, I will talk about first about components of edge networks, and then why edge computing is critical today, and edge computing in future mobility relationship and key concept of smart mobility, and how edge supports vehicle connectivity. And of course, at the end, I'm going to discuss a little bit challenges that we come across in edge computing. So anyway, edge computing is processing data close to the source of data instead of sending data to the clouds. And certainly it reduces delay, saving bandwidth, and enables faster decision. When we talk about key components of edge networks, certainly there are edge devices like IoT sensors, onboard computers, or cameras, smart cameras also. So the other component in edge network is, or actually edge nodes. They are logical and intelligent units that actually process, analyze data, and make real-time intelligent decisions. And edge gateways, connecting edge devices to network, translate local protocols from IoT sensors, and translate to something that is, or protocols that is understandable to edge servers and clouds. And also edge servers, hardwares located locally close to the source of data, which brain we can say that are edge nodes. And orchestration layer, okay, this is a system of tools, software-based, that monitor and manage different distributed edge network nodes. And it also localized and orchestrates loads among the nodes. And the connectivity layer, as we know, handling communication between edge components and cloud can be via 5G, Wi-Fi, dedicated short-range communications protocol, and also cellular V2 everything protocol. So what forces, first of all, make edge computing critical today? First of all, explosion of IoT devices. Today, there are over 30 billion connected IoT devices generating data almost everywhere. Average IoT device generates data from kilobytes to megabytes in seconds. It is estimated that IoT devices will globally generate amount of data of 79.4 zettabytes in 2025. Industry IoT and also healthcare IoT are among the fastest growing areas requiring real-time edge computing. The other force is certainly 5G mobile networks rollout. 5G technology actually promises low latency, particularly 5G standalone. A lot of applications coming with 5G technology, like augmented reality, virtual reality, smart factories, and of course, autonomous vehicles. They require real-time feedbacks. AI modules running on edge devices and edge servers, they allow edge network to make real-time intelligent decisions without depending on the distant cloud. And of course, security and privacy. Autonomous vehicles, healthcare, finance, defense, they deal with sensitive data, and sensitive data require to be processed locally. So in order to meet requirements of different regulations like GDPR, so edge computing and cloud are not opponents, they complement each other. Edge network, filter data, analyze data, and make real-time intelligent decision. But edge device are long-term data storage, performs advanced analytics, important for business reporting, and AI modules are trained there and then sent back to edge devices to run. So the future of mobility is connected, autonomous, and intelligent. At the core of this is seamless data flow between vehicles, infrastructure, network, cloud, and users. Edge computing enables fast, reliable, and intelligent vehicle communication. Processing data close to the vehicle is essential for safety, performance, and the future of mobility. Key concept of smart mobility that we discussed earlier is, but I would just point out and just cite it, certainly vehicle to everything. This communication actually provides communication between vehicle and other entities like other vehicles, infrastructure, network, pedestrians, and so on. And this communication requires ultra low latency. So where edge computing is critical. And also this data needs to be in real-time exchanged for safety and traffic efficiency. Software-defined vehicles are cars where some vehicle functions are controlled, updated through software, like advanced driver assistance system, like adaptive cruise control, automated parking, emergency braking, lane keeping, and so on. Powertrain, where optimization of the engine behavior, and also managing the energy of the vehicle itself, they are also controlled through software. And of course, infotainment, where information, entertainment, and connectivity service are delivered to the driver and the passengers. And also telematics, technology combining informatics and telecommunications that gather data related to vehicle and send to external systems. Information like status of engine or like fuel level or health brakes, something like that. Also speed and location of the vehicle, behavior of the driving, and also some some information from external environment like temperature, crash sensors. So all these data are sent to outside and to edge servers, and then they are displayed or reported to operators, users, and so on. So vehicle to everything, software-defined vehicle, telematics are some, I would say, global pillars of modern mobility. So how edge supports vehicle connectivity? As I mentioned, first of all, edge nodes in these so-called edge devices or edge servers, there is not just strict differences between edge devices sometimes and edge servers, because some edge devices can have different roles in this edge network, even to process and even to make intelligent decisions. So these in roadside units, for instance, where edge nodes are hosted, or base stations or onboard computers installed in the vehicle, they process local data, enabling real-time alerts like collision warnings or pedestrian detection. They reduces this round-trip time to cloud, which is important for actions that needs to happen in milliseconds. Offloads processing from vehicles. Many functions like ADAS, real-time navigation, hazard detection, are computation heavy, and edge servers process and fuse sensor data from multiple vehicles to detect traffic pattern and hazards. This reduces the processing burden on board computers that are installed in the vehicle itself, which extends vehicle battery life, important for electric cars. Improves also connectivity and bandwidth, acts as a local content cache. There are data that vehicles actually use very frequently, like a data map. Okay, also roadside units, they all use very frequently this map, and instead of download from cloud each and every time, these data can be cached locally on edge servers. And during idle time or nights or something like that, they can be refreshed. So it certainly speeds up access to these data and saves bandwidth. Also, optimizing network slicing and quality of service. As we know, in 5G standalone, network can be sliced vertically, logically, of course, where each slice has its purpose, like a purpose for critical vehicle communications, or another slide can be dedicated for entertainment system, and so on. Each of these slices has its own quality requirements, and this is exactly where edge computing helps, because it can helps in this to meet requirements regarding to reliability, data rate, and of course latency. Some of these network slices to meet quality requirements actually needs data to be processed locally. Edge nodes also collect and analyze data like weather, road conditions, traffic flow. With that data, system can adjust routes, control traffic, and help vehicles to drive smoothly. AI on edge devices make quick, smart decisions on local data, based on local data. So it enables to adjust driving behavior or reacting to nearby events. And also sensitivity data, as we earlier mentioned, generally speaking, but also in autonomous vehicles, for instance, location, driver behavior are considered sensitive data. So they are locally processed and not very much exposed to the cloud. And of course, security systems at network's edge can detect unusual activity intermediately on the spot. which is essential. And edge nodes run on roadside units, as I mentioned, base station, metro data centers, and system can grow and handle more vehicles and services, which actually show scalability, edge computing scalability, the ability of the system to grow, to adapt, to handle these increasing demands. And also, it can work with any car brand, road operator, or city system, and it ensures all parts communicate and cooperate. And also, we can talk about challenges that we come across in edge computing, of course, like security and privacy. There are a few challenges that I will point out here, but there are much more, of course, but the crucial ones are security and privacy. So edge devices have limited CPU memory and power, making it difficult to apply robust encryption. Data may travel from one node to another over public network, and it demands a stronger encryption, but strong encryption introduces latency. Scalability and management generally, edge computing network has a wide variety of devices, and these devices have different computing power, energy constraints, memory storage, and so on. Orchestration tools for distributed systems are still maturing. And also latency and bandwidth optimization that I cited, that I mentioned a few times. But low latency is the goal, there is no doubt about that. But not all applications and networks guaranteed. Network congestion and inconsistent bandwidth can affect real-time data processing. And also, keeping data synchronized across distributed nodes and cloud is essential, but technically difficult. When connection between between edge network and the cloud is broken, then of course edge network is designed to work independently. But once the connection is restored, then data duplication and data version conflicts may occur. So ensuring synchronization, data synchronization across distributed nodes and cloud is essential, but technically complex. And of course, lack of unified standards across edge networks, different vendors, that leads to integration challenges. Devices and platform may not communicate seamlessly. Limited power and resource constraints, they may restrict edge devices to functionality, and also infrastructure price and operational cost, initial cost can be also high. So if I need to conclude, maybe I can just say that edge computing is not just optional, it's foundational for intelligent, safe, and scalable mobility. But despite challenges, it's essential for the future of smart mobilities. Since we are limited with time, I missed to say something additional, like interesting numbers that I come across regarding saving, I would say, decreasing latency through comparison between edge and the cloud. So just give me, if you are interested in that, just to give, if we still have time. Okay, I would just say, for instance, if we compare this vehicle to everything use case, okay, like collision avoidance, traffic signal control, emergency braking alerts, HD map updates, so we can say that, for instance, with cloudy collision avoid latency with regarding collision avoidance, latency with cloud is from 50 to 100 milliseconds, and for edge latency is from 5 to 10 milliseconds. And also improvement is from 80 to 90%. And also traffic signal control, it's for, can you hear me? Sorry. Can you hear me?
Yes, yes.
Okay, sorry, because just to say that regarding traffic optimization, like in cloud with cloud, the latency is from 100 to 200 milliseconds, and with edge latency is 10 to 20 milliseconds. So just to summarize, and not to bother you with this lot of numbers, just to say that vehicle to everything use case, like a collision avoidance, when we compare between cloud and edge latency, improvement is from 80 to 90%. Regarding traffic optimization, like traffic signal control, the improvement is with edge computing is from 85 to 90%. Emergency braking alerts, 95%. And HD map updates that I explained, that are cached locally, the improvement is 90%. And of course, there are source examples that are cited here, but just for me is important that you have this to get that feeling how much this vehicle to everything communication is improved with edge computing. So this is it.
All right. Thank you so much, Gorana. I think what you presented was fabulous. I think it was giving a great message to everyone. Thank you so much. I appreciate
You're
that.
welcome.
If you don't mind, for the other speakers, would you mind to switch on your camera? Let's have a quick 10 minutes or more to brainstorm the Q&A session. I would really appreciate if you can switch on your cameras. Sunil, are you there as well?
Yes.
All right, fantastic. Okay, good. So the Q&A is, let me read out again. How should industry stakeholders, automakers, telecom providers, infrastructure operators, and regulators collaborate to treat 5G, V2X, and autonomous driving as an integrated ecosystem rather than fragmented technologies? Anyone wants to take it up?
Could you just read the question again, Ganesh, if you don't mind?
The question is, how should industry stakeholders like the automakers, the telecom providers like mobile network operators, infrastructure operators like the data center or towercos, regulators can collaborate to treat the 5G, V2X, and autonomous driving as an integrated ecosystem rather than fragmented technologies? Okay, maybe let me explain more. Yeah, you see, in today's world, what happened is that there's a lot of these car automakers around the world, mainly are dominating from the US, the China, and the Europe. These three, let's take an example. The automakers, what they do is that they coming out with these fantastic, fabulous sensors and ADAS and intelligent systems within the autonomy of the car itself. So they are not trying to see how they can work with mobile network operators, with the support of telecom vendors, like Qualcomm is leading in the 5G V2X for 5 or 6 years ago, pushing the V2X, which is vehicle to everything, vehicle to infra, vehicle to pedestrian, vehicle to you name it, or to connect to this cars, right? This is the project that but somehow along the line, what we noticed that there are some sort of a gap. There's two players. One is the connectivity players are trying to push for this V2X. On the other part, the automotive itself is driving without the connectivity. They say, hey, look here, I can do without the connectivity of the 5G. So the question is how we can actually put it together and work around.
So
Yeah.
I could try to answer.
Yep.
So I was thinking that actually government should take the lead to set some regulation and potentially some standard. As you may know, in EU, for example, they have forced, for example, Apple to adopt the USB-C standard to have all the cell phone using the same charger. And potentially they could use similar regulation to impose some standard for SDV. So it could be, for example, for the charger, where they could actually standardize actually the socket, because for instance, in Korea, I think we have 4 to 5 different type of socket, and all the charger need to have the capability to have the different socket. Otherwise, you cannot charge in certain part of the charger. So they could impose actually the regulation on this, the regulation on the, like the communication standard. They make the communication standard for 5G, for example. They could actually government could play a role here to set a standard, and potentially, of course, we think about like wider government that could set the standard, such as USA or EU or maybe even China. But the problem is, as you know, EU is super slow at setting any regulation. So it would need actually maybe some kind of government that are like how to say, adopting quickly the new technology, maybe like Korea, for example, where they are quick to adopt new things, to generate some regulation, and for a conference actually to suggest that this government is leading the edge on this technology, and suggest that other government globally use the same standard to standardize SDV actually.
Fantastic. Maybe I would like to add some points here, is that there was a statement saying that by end of 2025, there are expected about 67 million active automotive 5G vehicle subscriptions, with 3 million being low latency connections for autonomous and driverless cars. 5G offers a seamless handover between the cells without packet loss, which is a huge advantage for autonomous vehicles, and provide more option in that case. As you said, you were right, Lauren, that the US Department of Transportation released the V2X National Deployment Plan in August 2024 to accelerate the adoption of V2X technology for enhanced road safety. I think this plan is fabulous in terms of focusing interoperability with various different cars and mobile operators, privacy, setting goals for widespread deployment, and also the FCC, the regulatory in US, have announced final spectrum rules that allowing the C-V2X technology in the 5.9 gigahertz spectrum, just specifically for the automotive. On China, they have a national strategy for the Internet of Vehicles, IOVs, and opened over 5,000 kilometers of roads for intelligent V2X pilot demonstration in more than 90 cities. I think China is leading in this sense on the V2X. They are also starting launching various EVs simultaneously, and at least 12 CV2X equipped vehicle models has been launched in China as well. So I think overall, I think only these two countries are really going forward. You are right, Lauren, that Europe is a bit behind in that sense, still trying to formalize the whatever the regulation, right? I think they are very more careful in terms of regulation, in terms of safety and all that. Yeah. Anyone wants to add anything?
You're right, Ganesh. So what I would feel is, so since US is taking a lot of traction on this CV2X, so there is a mass deployment is going to happen in next upcoming years. For that, yes, of course, the 5G, which gives a very good good performance in the throughput and reliability, and also very low latency. Okay, 5G along with the V2X would make a very good improvement or the futuristic technology for the cars, for the automotive domain.
Gordana, you have anything to say?
Yeah.
No, actually, I'm still I didn't completely follow all speakers just because of my issue, but anyway, I chose generally this edge computing subject because it's certainly the focus of the future mobility, and certainly a lot of work is in front of us since it's a scalable system, this intelligent mobility. Certainly more issues will appear, and that maybe at this moment we are not even able to recognize. But I think that I believe in a bright future anyway, and I'm pretty sure that the answer to many things that we discussed here, certainly among other things, is edge computing.
All right. So thank you so much. I really appreciate all the speakers for your contribution today. I'm so grateful to for everyone to have we made it somehow for today. And thank you so much. Till we meet again, please do subscribe our YouTube channel. This video will be uploaded in a couple of hours, and we'll be distributing to the speakers and also to the community and the social media, and we're blasting for the next 1 month. I'm really grateful, and thank you so much for your support. Have a nice day.
Thank you, Ganesh. Thank you for organizing. Bye-bye.
Bye-bye.
Thank
See
you.
you.
Bye-bye.